Alright, time for another DraftScience video presentation. It just goes on and trying to reason with you people. Trying to explain that the physics, just like everything else humans endeavor to do, they're doing it not very well. And it's got big, gaping, monstrous errors in it, and you ought to take account of that. They're sort of obvious, and they're like religious notions. They're old artifacts. They're so vestigial. We can understand, with our more enlightened brains, that this was more like superstition than it was reality. It's like, the first person that ever used a lever, to move something was probably saying, gee, I'm making power. No, you're just using it differently. And, but the mistake could be understood, where they thought something, it's a little bit magical. When, it's not really. You can understand it. And physics hasn't fixed those parts. It still has some, shock and awe in it. It still has the effect of, not fully understanding and just going by some superficial, it seems like thing. So anyway, but there's just no willingness to accept what seems, all the evidence points to it. The history is just terrible for this kinetic energy formula. It was, the mathematics is just contrived in the sense that they made the mathematics is circular. They made everything else match this wrong answer, and so all the elemental bits are also just wrong because they've been contrived to make the outcome justify their belief. But you can prove it is nonsense with simple analogies to bowling balls and wrecking balls and all kinds of different things where it doesn't make any sense. Even bullets, and guns. You can point out that the heavy gun moving is the same energy as the bullet moving. And it's just the energy's in a different form. It's spread over different amounts of mass, and that causes it to have an effect that looks very different. But the effect isn't different. The same amount of energy is going both ways. Well, that could be understood, but no. And especially in the circumstance, again, where we can analogize things into space, because we've been there and done that and proven space is what we thought it was, empty and all that kind of stuff. And I can give you the rocket ship analogies and such, and point out how there can't be an opposite reaction from the environment. The environment doesn't care. You can't push against it. So obviously, all the rocket has, all the spacecraft has to navigate, is it has to give away momentum, and that's all it can do. And giving it away means it changes its own equilibrium. I mean, those are such simple arguments, but anyway. So, on the simple Quora question, how much does a stick of butter weigh when I drop it a meter? Another thing that physics really should have had an answer to. It shouldn't be that, they really should have mathematics to say if I take a scale and I put 100 joules of force on it, how much does it weigh? I mean, that should be an answer they already have in the book, right? They're already saying a Newton is the weight of a stick of butter, so they're already halfway there. And yet you can't get the answer. Okay, it's and their calculations are all this convoluted. So this guy posts a convoluted answer. He does an example with 2 sticks of butter, which I don't even understand. But even that answer is preposterous. 63 newtons, which even if I cut that in half and make it 32 newtons, you're talking about like over 5 pounds. And you know that when you drop a stick of butter, it doesn't weigh 5 pounds. I mean, 10 pounds actually. Your arm doesn't go, whoa, 10 pounds, 5 gallons of water. It doesn't weigh as much as 5 gallons of water. If I had 5 gallons of water on one side of a scale and I drop a stick of butter on the other side, I'm not going to lift 5 gallons of water. No chance. So nowhere even in anything called the ballpark. But a bunch of convoluted math, a bunch of blah, 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 And, for what? To get wrong answers. Oh, great. Useless answers. So, I have been, this was posted by INM. Why the hell can I post comments section? It all gets deleted. I don't know. I mean, YouTube's a pain in the ass. I don't understand any of it, frankly. I can't post on my own videos, which, from one channel to the other, which doesn't make any sense. So he wants me to look up this Ben Ryder guy, kinetic energy derivation. I can't even post those words in combination. Well, those words aren't blocked. I mean, somebody accuses, that I have a whole bunch of words blocked. I don't. I have 6 words blocked. The N word, I'm not going to go through the list of the stuff that I have blocked, but it has really nothing to do with this. It has to do with my personal information is blocked. And that's it. So all this, again, all these liars with their conspiracy theories, just constant lie after lie after lie, and then I'm supposed to defend myself against a bunch of lies. And here I am doing it again, which is just stupid. Because I have no obligation to keep defending myself against lies. Anyway, YouTube is ridiculous. Yes, it is. I was trying to get your opinion of that video. So it's a derivation video. Oh, what fun. But yeah, let's go through it. Maybe first, let's just talk about another example. I mean, it was in the Stephen Bro video, the use of levers. And levers sort of just prove the point, right? I mean, the lever's just an imbalanced scale. And so there can't be more energy on one side than there is on the other side. So it should be kind of a non-starter. So really you're just taking the basic idea of a scale. Okay, a little pivot point here, and you have to put the same weight on here and the same weight on here, and they'll be balanced. And they'll be imbalanced based on, if you double this weight, then this will be twice as imbalanced kind of argument. And so a lever is just changing the point at which the fulcrum is. So now you have an imbalance. And then you can balance the imbalance by just making this side heavier and this side lighter. And you can still have a scale, so to speak. So the idea is you can move a little distance here, and you can move a lot of distance here. All right, and so this kind of just proves the whole kinetic theory has to be wrong, because that this object's going to travel faster, but you can't do it for free. So you have to, if you're going to use the same force here to cause an action over here, that you have to make this 1/2 the mass. Right? So you're going to go half the distance here. You're going to go twice the distance here in the same amount of time. This is going to have twice the velocity. And the only way it works is this has to be exactly 1/2 as heavy as whatever's on this side applying the force. And that's the only way it's going to balance. So what's the rational... How do you account for this? Again, it just ends up being free energy if you use your velocity bias, because this side's going to have more velocity and less mass, and this side's going to have less velocity and more mass. But it's the same force is going to cause whatever force you apply here is going to be applied over here, and this little pivot is a very efficient way of distributing the energy, converting this into this. And your formula says there's twice as many joules here, 2x the number of joules leaving this side as there is this side. So, I mean, if I put this even horizontally on a table, you can understand it. I push it this way with a certain amount of force. Okay, I apply a certain amount of momentum, velocity, and mass to this side. I didn't make twice as much energy on this side. So if I'm using the same object, on here, I'd have to apply more force to lift this, to shoot this at the twice the speed. So let's see, it's probably not the best way to say it, because I want to make sure it's understood that it has to be consistently applied, like a spring is attached to it or something. You have to have a consistent amount of force. Obviously, gravity allows you to have the consistent amount of weight. But anyway, the point is their formula would say this side, okay, this one's 1/2 the weight, and this one's, so this is 1m, okay, and it has 2v. Do I want to use? No, I want to use, no, 1v. And this side has half a mass, and it has twice the velocity. And you know, so the answer here, as you're squaring this, is going to be higher than the answer over here, which is just 1. So you have 2 to 1. And, you know, whatever. Those probably aren't the best numbers to illustrate the imbalance, but I can just keep going out here, and I can keep creating more and more energy with the same action. And what sense does that make? You know, it's not more energy. Alright, so I didn't do that perfectly, but whatever. Close enough to pointing out that, I mean, it's in these simple devices already show that this can't be the right answer. I mean, I've given you the train analogy. That one you can see in videos. I mean, dropping the twice as much weight onto the train, and it goes 1/2 the velocity. There's no, you know, there's no, oh, it only goes 1.4 times. No, it goes exactly half. Alright, so you can't, and then I showed you the Professor Lewin video that clearly demonstrates that it really doesn't matter what's on this side, doesn't matter how heavy I make it, that no matter what, the spring is going to produce the 100 joules this way, and that's all it's going to ever do. And if I put the same weight cart on here, and I keep changing the weight of the cart here, as I double the weight, I have the velocity each time. It works. So I don't know why you people are just saying I'm going to defend nonsense and something's wrong, and you're just going to keep defending it. That's really depressing. Whoa, I didn't want to do that. Yeah, that was a mistake. Alright, I'll have to fix the mistake. Alright, should be back. Minor technical difficulties. Anyway, so let's play this. Oh. So far, not so good. It is playing. Sound. Where is that? It's not making any. Yeah, it does seem totally fucked. Alright, more technical difficulties. Alright, let's try again. Linux.
Why is it that kinetic energy is equal to 1/2 times mass times velocity squared? If I ask my students to hazard a guess at what they think the kinetic energy formula should be, they often think that it's related to mass and related to velocity, and might hazard a guess at mass multiplied by velocity. But this formula...
Right, and that would have been Newton's guess, and it was a pretty good guess, and there's nothing wrong with it, and it works. And, yeah, so energy is, again, these distinctions they wish to make between a force and something called energy, like somehow they're supposed to be different things when they can't be different things. And the same thing is true sort of for work. Work is just, the unfortunate part of work is that work you're trying to say what part of the action is my desired action. You're always going to do the same work, and that you're always going to convert your force into energy. Now the question is if you convert it into a bunch of heat or work that you didn't intend to do, well, that counts as, that comes out of your energy. So that's where they mess up work, is they want to try to say that you can do the work and lose the work, lose the energy, and that's how they justify their exaggerated perceptions of energy, is they just say you lost all of it, when no you didn't. They'll never show you losing it.
But it's wrong. It's not mass times by velocity, it's actually 1/2 times mass times velocity squared.
And that's just because you say so. It's not because evidence says so, or reason says so, or logic says so. And again, it's just an old artifact. It's a totem pole just sitting there right in the middle of physics. It's just this old, stupid totem pole. And they're still praying to it.
But why is it that we have a term in 1/2, and why is it that it's velocity squared?
Alright, so the half I'll explain, as I have explained in the past. It's pretty simple, because this is half Newton's mechanics, and Newton was well aware of a fact, that when something's falling in gravity, okay, it reaches 9.8 meters per second, okay, in terms of its velocity, but it only travels 4.9 meters to do that. So it didn't move at this rate. It moved at 1/2 the rate. Okay. So in a sense, you could argue that the real gravitational force is something like 0.2. Because if you add 0.2, okay, and then you add 0.2, and you add 0.2, and you add 0.2, and you add 0.2, okay, in each increment, then, you can get to your 10 total, your gravitational velocity produced by gravity. So in a sense, the 0.2 would be the relevant number from my perspective, because that's the number you're saying you're adding, with each bit of each increment of distance you travel. If you make that increment a standard increment, you're getting twice the value out of it. So you move that far, and you get twice as much value out of it. That's one way of looking at it. You could also do, a mathematical equation where you can figure out there's 15 units total. If I was just to say, it comes out to like if you multiply 15 into 10, you get 0.666, which is kind of nice. And you could argue that that's the what you start with, and then you just keep adding 0.66. So you add it the first time, you travel 0.66, so that means you went this far, and then you're going to add it again. So here's a new 666 added, and then you still have your previous velocity. Okay, so you always have to combine with what you've already acquired. Keeps happening. So this keeps happening, and this keeps happening, and each time. So now there's 2 of these, right? So the first time you only have 1 of those, and then you have 2 of them, and then you have 3 of those extra velocities from your previous acceleration. So anyway, there's different ways you can model it, is the point. But the simple truth is the half comes from the fact that your velocity reaches 9.8 meters, but you only traveled half a meter. You only traveled 5 meters, 4.9 meters. So your velocity and your acceleration, obviously you have to be accelerating at a rate faster than your velocity, in a way.
Well, to answer that question, imagine a car that's accelerated along a road by a force.
So again, why do this when we know that most of these circumstances aren't going to be cars accelerating? They're going to be cars coasting. They're going to be things that accelerate and then possess a force. So this is another part of this whole conversation that breaks down. There's a huge difference between you being a container possessing force and you being constantly forced. So F equals ma is a gravitational equation. It's one describing a circumstance where there's a constant force hitting you. So it's constantly giving you the little extra amount. It's only giving you the 0.66. It's giving you this little bit. Every second it's applying this little bit of push. And what's accumulating is your accumulated pushed velocity. That is, for each velocity you get to keep it. So when it gave you one velocity, then it gives you another one, and another one, and another one, and another one. You collect all of those, and those become the substance of your velocity. Ends up being the accumulated velocity, not the little push that it's doing. The last little push is still just one little tiny push. Even though you're going 10,000 miles an hour, all it's doing is adding a little tiny push.
F. Now, if that force is the only force acting on the car, then it should move with uniform acceleration.
So the uniform acceleration just has to do with how the spring uncompresses. So this, it's just basically telling you that this is how gravity works. So gravity is the 1/2 thing. Gravity does this 1/2 thing. Okay, everything else does some other thing. Okay, like a spring, the spring constant is really just saying it's not a half, it's a different, that red line goes this way or the red line goes this way, and it's not proportional anymore. So, at short intervals, it's a small amount. At long intervals, it's a large amount. So it changes proportionally. So if you compress the spring deeper, it pushes back harder. This 6 number isn't a 6 number anymore. This number changes as you change where you are in the spring. So you compress the spring a little, you get a little back. You compress the spring a lot, you get a lot back. It's not the same as gravity. So again, how can you use the same formula? Does it make much sense?
Speed up uniformly. But that's not always the case.
I guess I could probably use a little more volume, right? Yes, probably could. Hit the button a couple of times, that should do it.
To cars because of friction and air resistance. So instead of a car, I'm going to ask you to imagine a spaceship.
And so what does he do to the spaceship? He does exactly the same thing. He just talks about accelerating a spaceship, constantly accelerating, keeping the motor on. When we're really talking about things banging into each other, they already have their energy. They're not being constantly pushed. They're just being allowed to carry their impulse. They have a certain amount of energy, an impulse, and that's what they're carrying. And then they're going to transfer it to something else.
Now the spaceship.
So again, this formula really has nothing to do with the circumstances they're applying it to. They're talking about something under constant force, and all of these circumstances are really about not constant, and especially in the kinetic ball example, when there's no visible deceleration or acceleration. It has every appearance that all the energy goes out of this object and goes into this object, and there really isn't any, even my explanation of saying, okay, this one does hit it and this one starts giving it its stuff and it starts running out. There's no evidence that it even does that, because this doesn't have the velocity. It has it all at once. It instantly leaves at the maximum velocity. It doesn't slowly accelerate to the maximum velocity. It leaves at the maximum velocity. And this one doesn't slowly decelerate, because obviously if it was decelerating, it would be going, this one would have 10 and this one would have 0. Then this one would have 9 and this one would have 1. And this one would have 8 and this one would have 2. Right? But when I got to 5, I'd be in real trouble, because this one would have 4 and this one would have 6. Right? I mean, if this one has 6, then they're not connected anymore. How can the rest of the 4 get into this one then? So it can't be that way either. Not for hard, inelastic objects.
In deep space has no air resistance, and so when you apply a force to it, it really will accelerate uniformly.
So again, it's talking about uniform acceleration, which really doesn't have anything to do with, like I said, they can't do this formula to the two kinetic balls. None of this will work.
And the force
I don't even think it'll work in the lever experiment. I mean, this is just mush.
Needed to produce an acceleration is related by the formula F equals ma. The force provides an acceleration a on the spaceship of mass m. This will be the velocity time graph you'd get, and let's say that in a time t, the spaceship reaches a final speed of v.
Right, and if they use distance, then it would be the wrong answer, because distance will give you a different answer, because it only travels half the distance. So its velocity going by distance isn't 9.8 meters, it's only 4.9 meters.
So the acceleration of the spaceship is v divided by t, change in speed over time for the change.
So again, it's supposed to be a change. It's supposed to be critical to this, but again, the change is always them saying it started at 0 and it ends with some final velocity. So it always ends up being final velocity. So simply put, you could just kill the t by just saying 1 second. Then you have a equals v, and so then you have F equals mv, which is momentum, which is correct. So just by eliminating the time, by saying, okay, it's 1 second, I've already converted it into momentum. I've already said force equals momentum.
Now in that time, the spaceship will travel a distance given by the area under the graph.
Really isn't given by the area under the graph. That doesn't make any sense. Obviously, it's not a distance. So all they're using it for is to say the area under the graph is going to represent a distance. So the whole area, okay, would be traveling the entire, 9.8 meters. So 9.8 meters would be if the whole square was filled. But the acceleration means it's only half that because of gravity. So gravity is the only thing doing this straight line. Spring does some other line, going in some other vector. So none of this has anything to do with reality, and certainly there's no line for two kinetic balls. There's no line for Newton's cradle here anywhere.
Well, distance is a half times v times t.
All right, which, on its face, you're just saying no distance is you measure it on a stick, and a ruler, and that's distance. But anyway, technically, again, you can just convert that t into a 1 and get rid of it. And then you just say, well, what's your velocity? Half your velocity is the distance you're going to travel. Well, that's in gravity. So in gravity, to get to 9.8 meters, you only travel 4.9 meters. It's true. But again, what does this have to do with everything on Earth? Oh, it doesn't have anything to do. It has to do with gravity. This is a gravity equation. This is a constant force applied by gravity equation. It is not an equation you apply to everything on Earth.
Now we want to work out the energy gained by the spaceship.
I mean, I've never seen any Newton calculations where he's calculating other things, because the principal purpose of this formula was to describe the fact that that it is a constant force, and you're trying to define the constant force. That's what you want to know. What's the constant force? That's what this equation is trying to tell you. It's not trying to tell you how much total force there is.
And the energy will be work done by the force.
So this is all just made up. So work done by the force, they've decided to, multiply the force. So the work done has to be done just by the force. The force can't get anything extra. So you're multiplying a force times a distance. Now, aren't you really saying there has to be a constant amount of something then? What's the use of the word what's the use of the d here? Except to make more force, right? You're trying to make the force more powerful somehow by giving it distance. It's a force. I mean, you can't sit there and say the work done is something to do with the distance. Because in space, especially, the distance is forever. And again, this is an acceleration issue. It has anything to do with something's force that it actually has by momentum, which is the real deal. That's your real energy, is your momentum, your mass times your velocity.
Work done is force multiplied by distance. And so the kinetic energy...
So then he's using this distance formula, which is the distance formula in gravity, right? And he's saying work done, okay, generally speaking, anywhere on Earth has something to do with this definition of distance, which is half, which is aligning with an acceleration, not aligning, and a specific one in gravity, not all the ways you can accelerate on Earth. So it doesn't have anything to do with gas pedals and all this other stuff.
Of the spaceship, after it's been accelerated by the force, will be F multiplied by D. Says
you. I mean, there's no reason for you to think, again, kinetic energy. Now he's changed work done to kinetic energy and says they have they're equivalent. When, of course, they're not equivalent unless you're opposing a force. So the only way they could be equivalent is you'd have to have a known force that you're overcoming, and then the energy is the force you're overcoming the force with. But other than that, how can they possibly, why would you say they're equivalent? Because we know the work done is dependent on whether you lose any of the work. If any of your force is lost to some environmental disturbance, besides pushing a thing a distance. And so again, the obvious error here is just you're looking at it and you're saying, okay, let's just get rid of the K and just say energy equals FD. Well, the energy just equals the F. The energy is the force. So what's the D doing there? You're going to have the force more than once? No. If you're an object moving, you have an impulse. Once the impulse is gone, that's it. You don't have a constant force. You don't have a constant hand pushing you. You just have the thing moving.
Now we can simplify that equation further. We know kinetic energy is force times distance, but over here...
Says you. Again, force times what distance? I mean, it doesn't even make any sense. What are you talking about? What force, what distance?
Here we decided that force was equal to m multiplied by a.
And it could also be written as mv if we just get rid of time. And you're going to get rid of time anyway. He's going to make time a constant, so he's going to cross them out anyway. So now we know that a equals v, so now it's mv.
So we can replace ma where we had force. Similarly, we had distance here, and we can replace distance with a half vt.
Right, and we know that's only in gravity is it doing the half thing. So that's just a gravitational fact. It's not a distance fact for any other circumstance. So they're now applying some notion that every force has to go through this inefficient acceleration in the sense that, or you could say highly efficient, depending on how you look at it, right? If you look at it one way, you're saying, wow, gravity is really efficient. It got 9.8 meters of velocity and it only traveled half that distance, 4.9 meters. So it's producing a lot more energy than its traveling distance. Or you could look at the other way around and say, boy, that's pretty lame gravity in the sense that it only got you, you only moved you 4.8 meters, but you're supposed to be going 9.8 meters per second. How the hell can you only go 4.8 meters? You obviously aren't going 9.8 meters per second because you only traveled 4.9 meters.
And so we get the formula kinetic energy equals ma half vt.
So we know the half just has to do with gravity. Doesn't have to do with all accelerate. All accelerations don't accelerate at the rate gravity does. All interactions with objects. All objects don't interact as gravity force pushes things. So we know this 1/2 is just a gravitational formula.
Again, that formula can be simplified further. We know that the acceleration is equal to change in speed over time for the change. So we can replace the a with v over t.
Right, so he's just basically put momentum back into the equation in the sense that momentum is now the force. So you just saw him do it, because he's just going to cross these t's out. And so we have mv back in. Okay, even though they said force equals ma, they should just say force equals mv. And that is correct. And then once you know the force, why I already know what the energy is. The energy is the force. There isn't anything other than the force. And clearly with objects moving through space, again, they're not being constantly accelerated. There's no constant force. So why would you think they have anything other than the force that moved them, their momentum, and that's it. Something with momentum gave them momentum, and now they're moving with momentum, and that's all they have. They don't have any extra. So multiplying them times something makes no sense at all because you're just making free energy. So this is the free energy part. You already had the answer, mv. The 1/2 vt, they're just sitting there saying, I'm going to find an excuse to give it more energy than it actually has. Because that's all going to be fake.
You'll notice that there are two t's, and they should cancel. So cancelling the t's will give us this equation. Now you'll notice there are...
Let's also understand that it's supposed to be change in velocity over change in time. So, blah, blah, blah.
two v's. And v multiplied by v makes v squared. And so now we've almost got our kinetic energy formula. It's just a matter of rearranging the m and the half, and you get a half mv squared.
Right, so the half is from the rate at which gravity applies the force. So the acceleration is at half the rate of your velocity. That's why you only travel the 4.9 meters, even though you're going 9.8 meters per second, when you're done. So when you finally get to that 4.9 meter point, you're going 9.8 meters in velocity. But you only travel that, and so your average velocity is half your real velocity. And the average velocity is essentially what they're applying here. And that's why the half exists. And the squared exists because they made up this fake notion that distance has velocity in it. So they put velocity back in the equation again, even though distance really doesn't have velocity in it. And if you just measure the distance, it just happens to be a number. And if they just solved for this and then put that number in, then they wouldn't have v squared. They'd still have a wrong answer, though, because obviously you don't need any more than just mv. Your energy is your momentum. That's all there is. It's all there ever will be. That's all Newton ever believed in. This is all fake in the sense that they're implying that these are natural derivatives of Newton's mechanics when they're not. Newton knew that F equals ma was about constant force being applied, and it was a gravitational formula. It didn't have anything to do with things carrying an impulse of energy. And beyond the fact that then you just convert the a into a v, because you start with zero velocity and then you reach your maximum velocity, and that's all you have. That's your momentum. So the change is the total change in your velocity, which is your maximum velocity, and therefore you're done. Force equals momentum. And that's the right answer. And then you're done. That's all. All of this is their contrivance. Newton didn't do any of this. Work done equals F times d. Kinetic energy equals F times. That's not Newton's physics. That's their physics. And it's not really rational. There's no reason to think the work done has anything to do with just your amount of force. If you use your force, you don't have it anymore. That's the end of it. There's no constant force to resupply you with new force. You're not being constantly accelerated, so every bit of deceleration is a loss of your force, and that's all you have. It doesn't matter what distance you lose it over. It can't make any difference. You're going to lose it. It doesn't matter how much distance there is. All right, that's probably enough of that. It's probably enough of the whole, the whole conversation is pathetic. I have to keep doing this over and over again. So we will go to somebody. Oh, I'm back. So somebody indicated that somebody on Pierrot's video had left some link to this stupid thing. So this is almost like the bowling video. There's nothing in this that proves the kinetic energy formula. No, not even close. Blah, 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 blah. So we'll just jump through it real quick just to point this. He's just measuring the spring constant. So he puts a weight on the spring.
Make it vertically, just like we did in the spring lamp.
And
I'm going to take a couple different loads here, and this is like a 1 Newton load. So what's nice is it tells me the force. And all I'm going to do is I'm going to measure the stretch amount. So remember that it's not the total length of the spring, it's how much the spring stretch. So I would hold my meter stick here, and I would put the 1 Newton load.
So it's just basically figuring out where that line is. So gravity has a nice proportional straight line in the middle. Springs, this way or this way. They get tighter or looser depending on which way you're going in terms of how much energy they're going to distribute.
On this, and then I would read off how far the spring stretched from its natural length all the way down to here.
Right, and he's not going to get a gravity number 50-50 kind of thing. He's not going to. It's going to get, so he puts a heavier weight on. It's going to be a different number than exactly twice as much for twice the amount of weight. Twice the amount of weight won't cause twice as much stretching. It'll cause more than twice or less than twice. And then he's just going to do the same thing with the cart. He's just going to put the springs, pull the spring out, and just say the velocity changes. Now, he doesn't do any of the experiments, and we already know what the outcome is going to be, which is if I change the weight of the cart, that I could simply prove this whole thing is nonsense, because the same spring compression, if I double the mass of the cart, I will 1/2 the velocity. So there'll be no evidence of any of this kinetic energy stuff being real, because what I'll get are real momentum numbers. I'll get a half. If I change the mass, double the mass, I have to have the velocity. That's what I'll get is the real numbers. And if I do that, kinetic energy gets all wacky. And they know that. And frankly, they can't deny the experiments. Well, they can. They are. Plainly. They'll keep asserting that somehow the twice as heavy cart doesn't go half as fast, when they have no experimental evidence of the heavier cart not going twice as fast or not going half as fast. No evidence, and they'll just keep asserting it. So again, he doesn't do any experiments here. He just shows you how to do the experiment. So it's a completely meaningless, no evidence in here at all of anything other than, gee, I measured how I measured the spring constant, in the sense I measured what it's by what amount it changes with mass or with force, gravity. How much pressure I put on the spring, I get different lengths. So they do that with like a regular weighing scale, has a spring in it, the old ones, and all they did was the notches got smaller as you went further and further into the spring. So you could say like the first notch was big, and then the second notch was smaller, and then smaller, and then smaller. Each notch got smaller, where gravity has all the same notch sizes. It's a way of looking at it. Alright, so this really isn't good enough to even waste any more time on, blah, 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 blah. So, we'll call it a video. It's kind of a mess anyway. Nothing went exactly as planned, but, that happens. It's part of life. Yeah, so I don't think there's anything else I gotta say. If I do, I'll just make another video. What the hell? So, this has been a DraftScience video presentation and such. I can only reason with you people. I mean, I wish I could do something harsher. I'd like to be a lot harsher, but laws and such.